figuring out properties of polynomial graphs just from looking at their pictures. So if you look at the we will board over here, it says we will learn about properties of polynomial graphs. I will identify properties of a graph like this. Tell me something that you already know about that you can figure out just from looking at this picture. It is a graph. What? What the degree is? The least possible degree, right? We learned that on Wednesday. What was our shortcut for least possible degree? The turning points, and do what with those? Add 1. So like you could already tell just by, because it turns 1, 2, 3, 4, 5 times, so the least possible degree for this would be 6, right? 5 plus 1 is 6. What else can you tell just by looking at this picture? Something that we talked about Wednesday, some stuff that was just on your skill check. And behavior. What's up with these two ends? They're the same direction. What does that tell us? 2 pieces of information. Which 2 pieces? Even degree and positive a value, right? What other information can we tell? If you had the numbers written on here, what else could you tell? If you had like the coordinate grid, the axes. The zeros. This has 1, 2, 3, 4 zeros. That's the solutions where it crosses the x-axis. You could also tell the what? What's this point? The y-intercept, right? And so these are the kind of things we're going to be talking about today, but also a few additional pieces of information that you can tell from the behavior of the graph. Now this part of your notes, so here's how your notes work today. There's 2 examples, okay? This stuff at the upper right is the directions for each of those examples. This stuff at the upper left is like little hints for each of the directions. So the A, B, C, and D on these go together. So what I want you to do is take a minute and read the directions on the upper right, and then I'll tell you about those hints as we go along. So right now I want you to read the upper right of your notes for just a moment. Alessandra, read the A directions for us, please, out loud. Oh, I'm so sorry. Did you put food in your mouth? Okay, never mind. Han, read A out loud for us. I'm so sorry. That was bad timing. All right, thank you. State whether the degree of the function is even or odd. So just as a little reminder, if you were to go back to that left side of your notes and look at part A, there's your little hints, right? If the end behavior is the same, you know the degree is even. If the end behavior is opposite, you know it is odd. Hayden, what's up with the end behavior here? Is it opposite or the same? Opposite, right? And so, or did you say odd? You said opposite, okay. Thank you. So opposite end behavior means the degree is odd. It's very it's peculiar. All right. Alessandra, how are you doing now? Okay. Read B, the directions for B out loud for us, please. All right, thank you. So that's 2 things there. One is the zeros, which is the easy part. And then the second thing says to state whether the multiplicities are even or odd. So let's talk about what multiplicities even means. Multiplicity is like the word multiples. And what it's trying to tell you is how many times the factor for that 0, how many times it occurs. You know how sometimes when we're factoring and we get the same thing twice in a factored form? Well, this would give you the 0 of x equals 2, but it happens to, it repeats, right? So it has a multiplicity of 2. So something like this would mean multiplicity of 2. It's how many times that factor occurs. And it determines the behavior of the graph in this way. If the multiplicity is even, like let's say it's a double root, When the graph gets to that root, it will bounce or turn around. If the multiplicity is odd, like say that would look like this. You have the same factor 3 times. Now it just gives you 1 0. It just gives you a 0 at -5. But the fact that the factor occurred an odd number of times, the behavior of the graph means this. It will cross through the x-axis. It'll cross through instead of bounce and turn around. So that's an odd multiplicity. So here's how we put that together on this problem. First, we're going to write all the zeros, okay? So that there's a 0 here, here, and here. So the first 0 on the left, we're just going to write -3. And I'm going to write this vertically because I'm going to put more information on the side. So I've got these zeros, -3, -1, and +2. Here's where the multiplicity comes in. At this 0 right here, -3, the graph crosses through. So on your little notes right here, what does that say about the multiplicity? It's even or odd? Odd, right? So I'm just going to write M for multiplicity. The multiplicity is odd, okay? So I don't quite know how many times that factor occurs. I only know that it occurs an odd number of times. Now look at how the graph behaves at the 0, -1. It bounces, right? It doesn't cross through. It bounces and it turns around and goes the opposite direction. So what do your little notes say about that multiplicity? It is what? It's even, right? So the multiplicity at -1 is even. So it's either 2 or 4 or 6 or 8, or who do we appreciate? And then at the 0, 2, not 0, at the root 2, it's going to be even or odd? Even, right? Because it bounces there. That's you. So the multiplicity is even. And what we're going to use this information for is in part C to help us write the factored form. Aiden, will you please read the directions to C for us? Thank you. So that's 2 things. First is state the minimum degree, which we know how to do from our shortcut Wednesday. We count the what's in the graph. We count the what's and we add 1 to them. Do you remember? Kind of. Not quite a bounce. The turns, right? Bounces is, we use that word bounces more for the zeros, what's on the x-axis. But when we're trying to find the turning points for the graph, it could be anywhere on the graph. It does not have to be just on the x-axis. So here are the turning points. We have 1 here, a turning point here, here, and here. So how many turning points is that altogether? 4. And what are we going to do with that 4? Add 1. So the least possible degree is 5. It might not be exactly 5, but we know it's not less than 5. And then the second part of part C is to write the factored terms. So where do you think we're going to get those factors from? From the, what are those? The zeros, right? What factor gives me a 0 of -3? X plus 3. And here's the thing. We wrote that the multiplicity there is odd, meaning the factor repeats an odd number of times. We don't exactly know what that is. We just know that it's odd. It's either 1, 3, 5, or 7. Now we're talking about the least possible. So what's the least possible odd number that we could put there? 1 for the factor. So the least possible odd is 1. And then the next factor from this 0 is x plus 1. We know its multiplicity is even, so what's the least possible even that we could put there? It's 2. It's at least squared. Could be to the 4th or to the 6th, we're not sure. And then this last 0, positive 2, gives me a factor of x minus 2. Its multiplicity is even, so what's the least possible even number we could put there? 2. And if you notice here, let's add up these exponents and see what we get. 2 plus 2 is 4, plus 1 is 5, which matches the information we already put down from the turning point rule. So those things should match. And again, the way we know that these are at least squared, or that's at least to the 1, we know that from the behavior of the graph, from whether it crosses through or whether it bounces at the roots, because that's just how it behaves under those conditions. It seems a little bit like magic, voodoo, like, oh, you're just making that stuff up, but it's for real. And then D, so please read us the directions for D. Perfect. Now, please understand, by definition, those characteristics that we learned on Wednesday, do you remember what it said about the domain for every polynomial graph? It's going to be the same as this one. What's the domain for this one? Negative infinity to positive. For the rest of the whole semester, I know, it's just like a week or something, the domain is going to be negative infinity to positive infinity. And if you get that wrong, one of us is going to have to be fired. Probably me, because I didn't do my job. Correct. It's just part of the definition for polynomial functions. The range, however, can be different from time to time. Remember, the range is the lowest y value to the highest y value. What do you think that is for this particular graph? Negative infinity, positive infinity. So it happens to be the same in this case as the domain. Right. So I want you to take a few moments to try the second example. And then we'll talk about it, and then I'll give you your homework turned classwork. Please remember, I need to tell you about how to check for A, okay? But it's on part C. Can you please help me remember? If I don't tell you that on part C, I need you to tell me to tell you. Okay, part A was degree, right? Did you say even or odd? Even, that's correct. How did you know that that was correct? The behavior's up, yes, but more importantly, it's the same. Because it could be down, just like the Led Zeppelin song, and still be even degree, okay? Part B was what was part B asking us? Is that the zeros? Okay. How many zeros are there? 4. -3, -2, 1, and 2. And then we want to know the multiplicity, whether it's even or odd. What did you say for -3? It crosses, so it's odd. Looks like mod, but it's really not. What did you say for -2? Even, because it bounces there. 1 crosses through. It does not bounce and turn around. It crosses. So what is that? Odd. It's also mod. And what about +2? Even, because it bounces. So they're mod and even. C is the least degree. So you're looking for turning points. Did you find 5 of them? Okay. And then what did you do with that 5? That's correct. You added 1. And then the factored form, please remind me to tell you about A. I'm probably going to forget, even though I just now said it. X plus 3, odd means you put what for an exponent? 1. And then -2 gives a factor of x plus 2. What'd you put? If it's even multiplicity, it's at least 2 here. for 1, you should have put x minus 1 to the 1. And for the 0, that's 2, you should put x minus 2 squared. And then there's a little self-check here. If you remember, adding up the exponent should give you 6. So 2 plus 1 is 3, plus 2 is 5, plus 1 is 6. So that can match. Guess what I'm about to tell you that I didn't forget to tell you about? The a value. So after you get your factored form, you have to decide if a is positive or negative because it affects your final answer. What's the shortcut to look at on the graph for whether a is positive or negative? Remember? From a few days ago. Yes, I love it. Thank you. The right end behavior. Make a note somewhere to yourself. This. If the right end behavior is up, then A is positive. If the right end behavior is down, then A is negative. What is going on in this situation? It's positive because the right end behavior is up. Let me just tell you what you would do if you had determined that A is negative. This is really simple and it's really small. So pause your writing and give me all your eyeballs up here on the thing. All your eyeballs and attention. If the right end behavior was down, and therefore that meant A was negative, all you would do to your factored form, you would just need to add a negative right there. Okay? Now you don't have to on this one. I'm just saying 2 of your homework problems have that, so you need to check for it. Okay? That's all I'm saying. Okay, and then on D, D was domain and range. What did everybody put for domain? Every single one of you. Oh, that's it. You're out of the herd. Negative infinity to positive infinity for the domain. And the range is the lowest y to the upper y. What'd you put for the lowest y? You could estimate. 50, negative 52, negative 48. I'd take any of those. But what symbol did you put on the negative 50? Straight bracket. All right? Very good. Okay.